Okay, in this video we're going to look at solving absolute value inequalities involving greater than and greater than or equal to. So for the absolute value of x greater than 2, we want all the values of x on the number line that are greater than or more than 2 spaces away from 0 on a number line. So anything to the left of -2 or anything to the right of +2 will make this original inequality true. For instance, the absolute value of -10 is 10, which is greater than 2. So absolute value of x greater than 2 means that either x is less than -2 or x is greater than +2. And again, you are absolutely allowed to solve this like an equation and then start using test values for your absolute value analysis. So example 3, solve and graph each. We have the absolute value of 2x plus 3 is greater than or equal to 5. So that's going to mean that 2x plus 3 is less than or equal to -5, so that's going this way with the -5, and 2x plus 3 is greater than or equal to 5 is starting at there at that 5 and going the other way to the right. Subtracting 3 from both sides in each inequality, we get 2x is less than or equal to -8, or we have 2x is greater than or equal to 2. And so dividing both sides by 2, we have x is less than or equal to -4, or x is greater than or equal to 1. So closed circle at -4, shade to the left. Closed circle at 1, shade to the right. So any number that is either at or below -4 or at or above 1 will make this original inequality true. Again, we can look at this from a graphing perspective. In red, again, is the absolute value of 2x plus 3. In purple is y equals 5, the right-hand side. And what this is asking is, where is the graph of the absolute value at or above the graph of the horizontal line? So we notice that the red graph is at or above the purple line for values of x that are less than -4, such as -4.53. And it's also at or above the purple horizontal line for values of x that are 1 or higher, such as 1.43. So anything between the -4 and the +1 is below that graph, so we would not want to include that. Again, as an alternate solution method, we could treat it like an equation and solve it using test values. So we still get -4 and 1. And if we plug -4 and 1 into our original inequality, it does make our original inequality true. And then if we test out a value like -5, 2 times -5 plus 3 is -7. The absolute value of -7 is 7, which is greater than or equal to 5. So we would want to include any value to the left of -4. If we pick a value between -4 and 1, such as 0, 2 times 0 plus 3 is 3. The absolute value of 3 is not greater than or equal to 5, so we would not want to include that. And then if we test out a value that's larger than 1, such as 10, 2 times 10 plus 3 is 23. The absolute value of 23 is 23, and 23 is greater than or equal to 5, so we would want to include that. So again, this alternate solution method, you don't have to worry about flipping the inequality sign when you divide or multiply both sides by a negative. This method can actually be solved to any inequality we talk about in this course once you learn how to solve the equation. So as soon as you learn how to solve the equation, you will pretty much automatically know how to solve the inequality. Part B, absolute value of 2x minus 5 is greater than 3. Again, we'll just stick with this method, but again, feel free to use the alternate solution method at your disposal. So if 2x minus 5 is less than -3, or 2x minus 5 is greater than 3, so adding 5 to both sides, we get 2x is less than 2. Here we're going to get 2x is greater than 8. And dividing both sides by 2 in each inequality, we have x is less than 1, or x is greater than 4. So x is less than 1, open circle at 1, shade to the left. X is greater than 4, open circle at 4, shade to the right. All right, part C, absolute value of 2x plus 2 is greater than -2. And that's true for all real numbers, since the absolute value of something is guaranteed to always be greater than a negative number. Again, if we want to look at this visually, we could do the absolute value of 2x plus 2. So once again, that's in red. And we're going to graph -2. And what we're asking is, where is the absolute value graph in red above the horizontal line in purple? And that absolute value graph in red is above this horizontal line everywhere for all values of x. So all real numbers, since any possible value you plug in for x will make this original inequality true. Again, if you want to treat it like an equation, you're going to get 2x plus 2 equals negative 2, 2x plus 2 equals positive 2. Subtract the 2's from both sides, we'll get 2x equals negative 4. Here we'll get 2x equals 0. So we get x is negative 2 and x is 0. When we plug those values into our original inequality, 2 times negative 2 plus 2 is negative 2. Absolute value of negative 2 is greater than negative 2. So we'd have a closed circle here. When we plug a 0 in, 2 times 0 plus 2 is 2. Absolute value of that is greater than negative 2, so closed circle there. Test out a value less than negative 2, it'll make this true. Test out a value between negative 2 and 0, such as negative 1, it'll make this true. Test out a value bigger than 0, such as 5, it'll make this true. So every possible number is a solution on the number line. So since all test values work, our final answer is all real numbers, or this R symbol. All right, that about does it for this video. Thanks for watching. I'll see you